The overall goal of this procedure is to purify recombinant elastin-like polypeptides from E. coli by inverse transition cycling. This is accomplished by first collecting the lysate from E. coli cells that have expressed recombinant elastin-like polypeptide and removing insoluble cellular debris by centrifugation. The second step is to remove soluble contaminants by inducing the elastin-like polypeptide transition with the addition of salt or heat, then collecting the elastin-like polypeptide coacervate by centrifugation and discarding the supernatant. This step is termed a hot spin. Next, the resuspended elastin-like polypeptide solution is centrifuged to remove the insoluble contaminants. The soluble elastin-like polypeptide in the supernatant is retained and the pellet is discarded. This step is termed a cold spin. Repeat cycles of hot and cold spins until satisfactory purity of the elastin-like polypeptide is achieved. Ultimately, inverse transition cycling yields pure elastin-like polypeptide products that can be characterized for use in a variety of biomedical applications.
Elastin-like polypeptides purified by this technique have a number of useful applications, including biosensing, tissue engineering, and drug delivery, where the transition temperature and biopolymer architecture of the elastin-like polypeptide can be specifically tuned for each application.
To begin, express the desired ELP encoding plasmid in E. coli using the conditions described in the accompanying text protocol. After shaking a 1-liter culture in an incubator for 24 hours at 37 degrees Celsius, transfer the culture to a 1-liter centrifuge bottle